Um, so I'd like to welcome everyone to this industrial workshop on next generation carbon capture technology. For those who don't know me, I'm Nick Bevan, and I'm a CCUS. I'm one of the senior CCUS innovation managers who looks after the CCUS innovation program in the UK in BEIS. So that's the name is CCUS Innovation 2.0. And so without ado, we'll start with AECOM, who are leading this this study on BEIS' behalf. So we're really quite excited by the amount of progress we've seen on next generation research and development and innovation, slowly building up piloting, and so we're very excited to start seeing that kind of looking to deploy in the UK, from the 2030s. And so this study is meant to help companies think about that. Okay, Andy, if you want to make a start.
Okay, yeah, thanks, Nick, and thanks again from me to everyone for taking the time to join today's call. My name's Andy Cross, and I'm AECOM's project manager for this review of next generation carbon capture technologies project that we're undertaking for BEIS, along with the University of Sheffield, and I'll introduce you to some of the other members of the AECOM and University of Sheffield team as we go through the call. So this workshop, as Nick says, is the first stakeholder engagement activity associated with this study. So the first thing we're going to do through the workshop today is actually introduce the study and its objectives and the objectives for today's workshop. Following that, we're going to summarise the types of technologies that we'll be considering in the study. Then we'll enter into our first interactive session where we'll be asking you to provide some input and your thoughts on some of the issues that we're looking to cover in the study. The first interactive session is intended just to capture where the various industrial sectors are on the road to decarbonisation with respect to progress, approach, and the technologies that may be applicable. I'll explain more about how the interactive sessions will work when we get to them, but you will need a web browser available to be able to take part in those. So following that, the next part of the workshop is intended to explore the opportunities and barriers associated with next generation carbon capture deployment in specific industrial sectors. So we've got a brief presentation to start to discuss some of the generic issues that apply to most technologies and applications. And then we'll dive into the next interactive session to seek everyone's views on that. Following that, we'll talk through some of the key dates for the next stages of the study and how it fits into call 2 of the CCUS Innovation 2.0 program that Nick just referenced, and other BEIS and ZIP opportunities. Okay, we'll then finish the workshop with an open discussion on key issues that may arise during the workshop, as far as time permits, but we will look to wrap up within the 2 hours that have been allocated for the workshop. I should also mention, as I believe you should be aware, that this meeting will be recorded, but we'll stop the recording when we get to the open discussion elements. Okay, so if you can bring the next slide up, please. Yeah, so before we launch into all of that, though, we just wanted to introduce the project partners for those of us that aren't familiar with us. The team delivering this study for BEIS is led by AECOM. We're a global engineering and environmental consultancy working across a wide range of infrastructure and development markets. In the UK, we have ongoing active involvement in carbon capture project development and other energy transition technologies. We offer we're offering currently a variety of technical consultancy services in relation to carbon capture projects, and we've worked on many UK projects as well as developments overseas. AECOM is supported in this study by the University of Sheffield, and specifically John Gibbons, Professor in Carbon Capture there. Many of you will know John. He's had a long career in carbon capture and energy technologies. He's also been a director of the UK CCS Research Centre since 2012 and is involved in the TERC test plant that operates out of the University of Sheffield. We've worked with John on previous BEIS projects, and his knowledge and perspective will be used to guide the direction of the project and review the results produced. So the study itself, the overall objective of the study really is to support BEIS's policy and decision making on innovation funding for next generation carbon capture technologies, particularly inform call 2 of the Innovation 2.0 program in May next year, as I said. More specifically, the study will undertake a review of next generation technologies as they apply to industrial, waste and energy sectors, and develop a techno-economic analysis of a range of technologies and applications to provide a comparison against a state-of-the-art benchmark, which is considered to be an amine solvent post-combustion plant. Alongside this, BEIS wish to understand the applicability of next-generation carbon capture technologies to different industrial sectors, help UK industry understand next-generation carbon capture technology, and engage with industrial sites to understand site-specific challenges and the cost of deploying the technology in different industrial sectors. which is where today's workshop and subsequent stakeholder engagement activities in the study will come in. The study is aiming to focus on the most mature next generation carbon capture technologies. Hence, the technologies that will be the focus of the techno-economic analysis will need to be at a technology readiness level that means they have the potential to deploy on industrial site to the scale of approximately 1,000 tonnes of CO2 per day from between 2030 and 2035 where possible. And just to confirm, the study is not considering CO2 transport and storage, so we're assuming that that infrastructure will be in place to support the deployment of carbon capture technologies on industrial sites. And also we're not considering hydrogen production, as that's a subject of separate work within BEIS. Okay, next slide then please, Kim. So the workshop objective, what we're trying to achieve today, the purpose of today's workshop is to introduce all of you participants to the study, let you know what it's designed to achieve, and to invite your input and engagement and demonstrate the potential of next generation technologies to industrial users and developers. It always goes without saying that all industries will be required to decarbonise over the next couple of decades to meet net zero emissions targets. And this may be through the use of carbon capture or alternative, potentially fuel switching, process modifications, or a combination of those and other technologies. Where carbon capture is a potential solution, we'd like to gain an understanding from the various sectors represented today of what technologies are applicable, where you are along the road to developing and deploying carbon capture technologies, and what you perceive as the most significant opportunities and barriers to the deployment of carbon capture as a solution to decarbonisation. This will be through the interactive sessions that we'll come to later in the presentation, and also the open discussion, as I said, and subsequent follow-up. So with that, that sort of introduces you hopefully to what we're doing, and particularly what we're doing today. I'll then hand over to Clym McKenzie. He's going to summarise the range of carbon capture technologies that we're anticipating considering within the study. So Clym, over to you.
Thank you, Andy. We'll now take a quick look at some technologies that can be used for carbon capture. While not wishing to spend a lot of time presenting information that many attendees will already know, to ensure a common understanding, we'll talk briefly through the main carbon capture technologies, the concepts that will be reviewed as part of the study. We should emphasize that the study is not intended to be exhaustive. And one of our early activities is to undertake a high-level review of a wide range of technologies. The examples presented here have been selected as potential candidates that may already be under investigation by some of the people on this call for deployment at your sites. So, separating from CO2 from a gas stream is not a new process, as we no doubt all know. Since the 1930s, CO2 has been separated from raw natural gas to create a high concentration stream of methane for distribution and use. Since then, a variety of technologies have been developed and used for natural gas processing and other refinery operations. There are also well-established processes and markets for the use and capture of CO2 in other industries, such as food and drink. CO2 produced during the manufacture of alcoholic drinks, for example, is relatively easy to capture due to its high purity. It's used for a number of purposes, including carbonating beverages and food packaging. Future applications that may see carbon capture and the purpose of this study are where it's widely accepted that CO2 capture and storage on a larger scale will be required to some degree to meet our net zero targets. There are a wide variety of different potential applications in power generation, industry, waste management. The emission streams that are being targeted have different characteristics, often including low concentrations of CO2 and chemical contamination. In general terms, higher CO2 concentrations, more specifically lower levels of contaminants, are an advantage for carbon capture. However, technical solutions do exist for capturing low concentrations of CO2 and contaminant removal. First one we'll talk about is capture of CO2 using solvents. I'm sure a lot of you have seen this flow sheet before, and this is one of the most common technology types and is receiving a lot of attention at the moment in relation to development of large scale capture projects. The basic process involves cooling to condition the flue gas, absorption to dissolve the CO2, solvent regeneration to release the CO2 as a concentrated stream. From the regenerator, the CO2 is sent for further conditioning, onward transport, and sequestration. The current state-of-the-art amine solvent capture will be considered as the benchmark for our assessment of next-gen technologies. The potential for innovations in solvent-based carbon capture will be explored, and in this review, we'll consider that largely as incremental performance improvements, such as optimization of flue gas pretreatment or energy management through means such as lower energy solvents, water lean solvents, heat integration, as well as others. Like any new equipment being installed, users of this technology should consider the track record in a comparable application. Variations of this technology have been used more widely in some industries than others, and porting from one flue gas to another leads to a host of new parameters that need to be validated. The next technology we'll consider is capture onto solid media, either with pressure or temperature swings, to capture and then release the CO2 for onward conditioning. The need for a regeneration part of the cycle does create the need for more than one vessel in what may essentially be akin to a batch process. So pressure and temperature swing adsorption processes have been used in gas processing industries for decades. I mean, take the emulsive dryer and any instrument air package on any chemical plant. The above example in this photo is from a landfill gas upgrading project where the CO2 is removed to produce a more concentrated stream of biomethane. In this case, the rejected CO2 is likely currently vented to atmosphere, although things may change in the future. Solid sorbent technology is used to capture CO2, being used to capture CO2 from a flue gas is a less well-developed technology at a large scale. So as with many carbon capture technologies, there's a need to carefully control the quality of the incoming gas, and introduction of excessive quantities of dust or other contaminants will damage the porous sorbent. So we'll also be considering fuel cells for carbon capture, which combine a fuel with oxygen to provide some electricity, as well as oxidized products such as CO2 and water. Due to the way they operate, certain types of fuel cell can be used to concentrate CO2 in a gaseous emission stream. These fuel cells could, in the future, be used for carbon capture applications on a large scale. This system may be more suited to where there is a local demand for the electricity generated. Moving on to membranes. So membranes are used in a wide variety of applications. They're being considered for different CO2 capture applications as well, and will be one of the technology types we consider. The materials used in the membrane allow certain molecules to pass through while retaining others, and this creates the separation of a concentrated CO2 stream. Like the sorbent technologies we looked at earlier, membranes have various existing gas processing applications. It is important to note that membrane use for capturing CO2 from emission streams with a low concentration of CO2 is less well developed at present. So next up, we have alterations to existing processes. So take, for example, in this case, Calyx's lilac process, which could be applicable to the lime and cement industry. In this particular example, limestone is heated indirectly in a tube, and the CO2 driven off, which emerges in a relatively pure form. The CO2 is much simpler to purify than relatively dilute CO2 produced during a typical cement manufacture process. alterations of this kind to various manufacturing processes have the potential to dramatically reduce carbon capture processing costs if applied. However, these are industry and process specific. The calyx process is specific to lime and cement manufacture. Later in one of the interactive sessions, we would be interested to hear about the process alterations that you may be considering that would be of benefit to your industry. Okay, so this is the part of the workshop where I note that carbon capture is an active area of research and has been for some time. There are a wide variety of potential concepts and options available. Some of them have the potential to be world-changing inventions, and the people developing them are very enthusiastic. Appropriate scrutiny of the technologies and realistic expectations are required. With the best will in the world, many technologies are in the early stages of development and may be a long way from being ready for commercial deployment. In the context of the climate emergency, time to market at an effective scale is an important metric, which should be included when we're measuring innovation. So even for the more developed technologies of the kind that we've looked at in the previous slides, due diligence, including scrutiny of the track record and operational performance in real life applications, is a vital step as we move from test campaigns and so on to appropriate full-chain, full-scale projects. I would now like to conclude the technologies review section of this workshop. The review will place a strong emphasis on technology types that have the potential to be commercially deployed at between 500 and 1,000 tons of CO2 per day by 2030. This review will also consider novel or next-gen carbon capture technology that can be commercially deployed at 1,000 tons of CO2 per day or greater by 2035 in industry, waste, or power. Okay, so thank you. We'll now move on to the first interactive session, which will be chaired by Andy.
Okay, thanks, Clint. Yes, so as Clint says, we're going to move into the next, the first interactive session, where we'd like to consider the current status of progress towards decarbonisation in the various industry sectors represented. So move on to the next slide, please, Clint. Yeah. So for this, we'll be using, as I said, the XLEAP platform, and thanks to Mark Pullen at BEIS for putting this together, and Mark will be pulling the levers in the background as we go through these sessions. To take part in this, you'll need to launch the XLEAP platform in a browser, and Karis Blunt has or will be putting the link for that into the chat. So thanks to Karis for that, and for setting it up and controlling everything on the call in the background. Don't do it yet, but when you have clicked on the link, you'll be asked to join the session, and then Mark will navigate us around the various questions. For many of the questions, we will ask you to pick your team, as it's called in XLEAP. Unfortunately, that's the hardwired choice of language that's in XLEAP and isn't necessarily a great description in this context, but essentially we're asking you to identify the broad market sector that you're aligned to give some context to your responses. The choices are either that you'll be giving are either a particular industrial sector, technology developer, academic, and where you can choose not to align with any of these. You'll be asked to specify your team for a number of questions. So could I ask you to be consistent in what you choose as you go through the various questions, so that the results we get are as consistent as possible. I should also point out that all of the responses really are anonymous and are just tagged with the team that you select. So feel free to express your genuine view, but obviously the rules of respect for others' opinions and comments go without saying, really. So, as I said, the questions in this session are asking you for your views on the potential approaches to decarbonisation in your sector, your currently anticipated timescales for deployment, and the carbon capture technologies, if any, that may be applicable to your sector. So please can you now go into the XLEAP platform, and Mark, could you launch the first question as we head into that, please?
Hi Andy, it's Mark here. Just to say, I've just opened the first question for you.
Great, thanks. Yeah, I think I'm sharing that on the screen. All right. stop screen sharing. Yep. So if everybody's in that question, thanks, Mark. Yep. So we're asking you here to rank the different approaches that you're considering for decarbonisation, excuse me, in order of priority or potential for your application. You can do that by clicking and dragging the lines into the appropriate order, and you then need to hit the submit tick in the bottom right of your window, and that will submit your answers so that Mark can compile the results and get a quick view on the outcome of that. So we'll give you a minute or two for that, and then once most people have submitted their responses, Mark will close that question and bring up, and we can have a quick look at the results.
Straight to results, Andy?
Yes, please. Yeah, thank you. Yeah, we'll see
Okay.
how that's looking.
Okay. Yeah, let me just.
Great. Okay. Well, thanks everybody, and thanks very much for contributing to that. Useful results that we'll be able to use to inform our review. So we'll move on. Can we move on to the next question, then, Mark, if that's okay? Have a look at that. And so,
yeah, your screens are changing now.
Great. Thank you very much. Yes. And again, so I'm afraid we do have to select your team as you go into each of these, and if you can be consistent, that would help in interpreting the results. This one is asking a fairly simple question about your currently anticipated timescales to decarbonisation, and when we've identified sort of full scale or near full scale decarbonisation of individual sites. Please be honest in responding to this. As I say, the responses are anonymous, so BEIS' decarbonisation police won't be after you, but if you can, for this one, you just need to select one answer for the sort of anticipated timescale, and submit. Again, click the submit tick at the bottom right, and we can have a look at where people sort of see themselves going with decarbonisation on the way to 2050.
Hi Andy, there's a clarification question in the chat. Someone's just asking, by decarbonisation, do you mean 1 net zero, 2 carbon neutral, or 3 zero carbon?
I think carbon neutral is probably the most relevant measure there.
Thank you.
Thanks. Obviously, you know, we're anticipating on individual sites that the potential to offset may be limited, but you know, across the market and the whole piece, carbon neutral is where we're aiming.
And this time, let's have a graphical display, and that your screen should be changing now. And
that's quite a strong trend. Right, so by 2030, which is really where we're looking at in this review for the next generation technologies, is the strongest candidate. So that's useful, interesting. So if you're ready, yeah. So if you're ready for that now, Mark, shall we?
Okay, let's look at the next question then.
Yep. Thank you very much.
The next question, again, a slightly different format. Invites colleagues to share the most promising next gen tech for carbon capture, and we've got a number of options on the screen there, but you can only select up to 4. So basically, we're saying what are the 4 top promising next gen technologies for carbon capture?
Yes, I think I'm right in saying, Mark, you can select up to 4. You don't have to select 4. You can, and we like up to 4, but once you've selected those.
That is true.
Yeah.
let's get the results back up on the screen. Here we go. Again, we've got, oops, sorry, I missed one. We've got a bit of a breadth, got a range there.
So yeah, some quite strong trends there that seem to be reasonably consistent from what we're seeing, and probably covering the technologies that we might have expected, particularly given the timescales that we're all working to, and seem to be aligned between this study and where people are expecting to be. So that's
and quickly for the chaps who mentioned other, there will be an opportunity for you to provide that feedback about what some of the other ones are that you have on your mind, and again, it can all be done anonymously in the discussion later on.
Yeah, okay, in fact that does take us on to the final part of this interactive session, and this is an opportunity for some open discussion around the approach to decarbonisation in the various sectors. So Mark, if you're able to move on to the next part of this, then there's a box here for each of the teams or sectors that we've identified. So if you click on the enter button in the bottom left hand corner of each of those to go into the relevant sector, then you're able to actually enter sort of open comments and also comment on other people's thoughts and comments in the box. So if there are other technology or specific technologies that you're considering or you believe have potential that haven't been mentioned yet, then please feel free to enter that, and we'll give 5 or 10 minutes to the opportunity some open discussion in this area. And
also in the energy from waste and biomass power thread, there's just a mock-up template of what you should be seeing, and how you build on other people's comments. If you want to have a quick look at that before you.
Okay, that's great. Thanks very much, everybody, for your contributions there. We've got some really good dialogue going on there. I think what we might do to allow that to continue at the risk of people getting distracted is kind of move on with the next part of the presentation. Okay, so now we've looked at sort of the generalities of the approach to decarbonisation across various industrial sectors. We're now going to start to get into the nitty-gritty of how next generation carbon capture technologies may be deployed in those sectors, and particularly by looking at the specific opportunities and barriers associated with them. David Memnior from the AECOM team is going to introduce that to lead us into the next interactive session by going through some of the maybe more generic opportunities and barriers that apply to most technologies in most applications. Then we'll move into the next interactive session to look at some of the more specific issues for the different sectors. So if I can hand over to you, David, thank you very much.
Yes, thanks very much. So yeah, I've just got 2 slides to present today on the opportunities and barriers. If we can have the first slide, please. So decarbonisation will form an important part of many corporate strategies, and of course, developing a CCS project is one way to achieve this. It's also potentially beneficial for the reputation of companies. So if companies are seen to be taking an active approach to decarbonisation, this can present them in a good light to investors, customers, and indeed even to employees of the company, helping to attract and retain the best staff available. Development of a carbon capture project can also offer opportunities in relation to competitive advantage. So I would say particularly if and almost definitely when the cost of emitting CO2 increases, having a carbon capture project and the ability to operate with lower emissions of CO2 has the potential to provide a competitive advantage for these businesses. There is also the potential on the horizon, I'm sure many of you will know about, of cross-border carbon tariffs, meaning that for certain products, the CO2 emissions associated with the product will be measured, and therefore there'll be tariffs applied when these are traded internationally. So if you have a certain process, let's say a glass, steel, or cement, and you can produce a low carbon product, if, and most likely when, carbon tariffs are introduced with border trading, then this could be a competitive advantage in the export market. Development of carbon capture projects also is an opportunity to attract investment to your business. Years down the line, when carbon capture is a common commercial reality, there'll need to be large amounts of public and private funding mobilized to allow these projects to be constructed. And that being in part of this is an opportunity to attract investment into your business. In the closer term, there's also the opportunity for the development of demonstration projects. So these can be funded in a slightly different way. There is a need to show that these technologies work well and to learn how to improve them, make them better, and also that they work in different industrial applications. So in the near term, there will be a need for projects to be developed in the UK that show these technologies working at different industrial sites. And this is another potential way that you can develop a project and attract investment to your site. The last opportunity on this slide, it's really a driver. It's the ability to keep operating. So this might sound dramatic, but as the years go on and the pressure increases on reducing carbon emissions, reducing your emissions may be a requirement to keep operating. Again, as I said, it sounds alarmist, but you could already say that was a factor in coal-fired power generation being largely phased out in the UK, that there was no a successful way of mitigating CO2 emissions. So this is an important factor to consider in relation to carbon capture projects, as things can move faster than might be expected. So if we move on to barriers, these are general barriers for carbon capture projects. Now, some of these barriers, as we go through them, might seem quite fundamental and difficult to get round, but part of the point we're trying to make on this slide is that they are difficult barriers, but there's ways around them all, and actions are being taken to overcome these barriers. So if we think about the first one, CO2 infrastructure. Now, by infrastructure, I mean pipes for transporting CO2 and storage sites. Currently in the UK, this infrastructure doesn't exist. But as many of you will know or have read about, there are plans for clusters of carbon capture projects to be developed. And it's fully expected that as these clusters are developed, they will indeed grow and more clusters will become available. Further opportunities in relation to transporting and storing CO2, such as rail transport or transport by ships and other ways of exporting the CO2 from your sites. Cost of emitting CO2 to the atmosphere is also clearly a barrier. In simple terms, for most industries at present, it's cheaper to just emit the CO2 to the atmosphere than try to come up with another solution. The way that this barrier is overcome is through a robust system of regulations, taxes, and incentives to alter the cost of emitting CO2. Now, the government and indeed any informed party or anyone who's had any involvement in this type of thing will know that coming up with that system is not an easy task. However, it's very acknowledged that it's an important set of taxes and incentives to have in place, and things are developing in that area. The politics around it are shifting. Then the next point on this slide is alternative decarbonisation options. So this is other ways of decarbonising at a particular site or in a particular industry. Now, this is on this slide as a barrier to the development of carbon capture. And indeed, it is a barrier to the development of carbon capture. But I believe it should be viewed positively, because ultimately our end goal should be low cost, low risk, or controlled risk decarbonisation. And if there's other options available at particular sites, so examples might be electrification or fuel switching, a change to the process, then yes, of course, this is a barrier to carbon capture, and it's something we have to mention here, but it's an opportunity for that industry, and certainly shouldn't be viewed negatively. In terms of alternative decarbonisation options, this is certainly something we'd be interested to hear about in the next interactive session for your particular industries, if there's other options that you see as favoured at this current point in time. The next point in the slide relates to technology risk and potential impact on your existing process plant. As Clem mentioned at the start of the presentation, some of these technologies are more developed than others. And indeed, even for the developed ones, some of them are being used in different applications, which inevitably has a degree of process risk involved in it. So to an extent, this is a barrier, but I think what's important to understand is that there are ways of addressing this barrier. And these are engineering practices like assessing the track record of a technology, or looking in depth at a technology and understanding where exactly the risks sit and how these risks can be mitigated and allocated to the appropriate parties and basically managed. So this is the type of exercise that companies like AECOM are actively involved in, looking at risks for different technologies and how they're managed, and understanding these on behalf of developers and potential operators of these types of technologies. Now, the last point on this slide before we move on to the next interactive session is just about public perception. So, I mean, I think this is definitely not unique to carbon capture. I'd say for any new technology, it's important that public perception is understood and managed. The responsibility of this really falls into all parties involved. So the government has a responsibility, but also industry, technology suppliers, academics, consultants, really everyone has a responsibility here. I would suspect at this point in time, probably many members of the public either don't know what carbon capture is or don't have a strong opinion on it, which is a fairly neutral public perception. But there are some issues that could emerge that we, as an industry group, would need to be aware of. They might include safety relating to transportation and storage of carbon dioxide, or they might include the risk around placing reliance on a technology which has yet to be developed, has a potential to take emphasis away from carbon reduction measures which could be implemented at present. So that's a very brief overview of the general opportunities and barriers for carbon capture. I think we'll now move into the next XLEAP session, where we can hear about more specific opportunities and barriers.
Great, thanks, David. Yeah, so Yes, we'll shortly be launching back into XLeap. So Mark, if you're able to load the second session and bring that first question up, and if everybody can move back into XLeap.
Cheers, Andy. With the next set of questions, we've got a set of questions on this occasion around carbon capture deployment. They're coming on your screens now. You'll see there's 5 there. Each of these questions, there are potentially 4 responses, and there's in the brackets it explains sort of what each of the potential responses are. So the 5 questions we've got here are around at what scale do you envisage deploying carbon capture technology? The second one is, as an industrial operator, when do you anticipate deploying carbon capture at full or near full scale on individual sites? Thirdly, at what scale would carbon capture have to be demonstrated for you to consider commercial deployment? Then for how long would carbon capture have to be For how long would carbon capture have to be demonstrated for you to consider commercial deployment? And fifthly, what total proportion of CO2 emissions do you anticipate being able to capture from your plant at full deployment? As I said, there, each one of those says sort of 4 options, which we're inviting you to sort of share with us. If you generally don't know or it's not relevant for you, click on the abstain button, and that will involve.
Mark, am I right in saying it is possible on some of those to add a comment to sort of explain or support your selection? Is that?
Yes, you can. Can you see it? So you're absolutely right. So depending when you come to answer a question, depending on your browser setup, basically, Andy, you may see that prompt straight away, or it will appear when you come to answer the question. So I think we should give colleagues a few minutes there because we're asking quite a lot.
Yeah, no, it's definitely there's need time to think about those and answer them, and probably worth pointing out that I guess some of the questions are sort of fairly simplistic questions associated with very complex issues around deployment of emerging technologies and specific applications. But what we'd like is sort of an overall view on your attitude to deployment risk and how it relates to the scale of the carbon capture that you'd anticipate deploying in your particular application. So if you can sort of select one of the multiple choice answers for each question and maybe sort of add a commentary to explain it or substantiate it, that'd be very helpful. Great. Yep. Thank you very much. Thanks, everybody.
Okay. Here we go. So the results that you will see them. I will explain it because we're looking at 5 sets of results here. So let's get them on the screen. Let me just focus. So let's just get these going here. Just going to change the screen a little bit more. So what you will see at the end of each question is a little down. There's an arrow. If you click on that, you'll be able to see the spread of results as well. And if you will also see a little sort of grey box with a tick on it, and you can see the comments also put there. So there's quite a bit here that takes a little bit of navigating to see the results. And again, what you see and how you view it will depend. It will vary a little bit depending on your browser settings. So, and the reason why you're hearing a little bit of hesitancy in my voice is because the view on my screen is different to the view that's being displayed. I can see on the Zoom call, but you've got it all there, just slightly different. And I think what's interesting here is looking at how the results are coming across the range. So it's the mean is less relevant here. I think in some ways it's looking at the spread. So if I look at what total proportion of CO2 emissions do we anticipate being captured, significant number of you are saying more than 90%. With that comments, because I see box 4, it's got a lot lot more sort of ticks than the rest of the other boxes. Andy, what do you make of that?
No, that's great. Yeah, that's really useful, and thank you very much for the comments and explanations that you've given behind those as well. That's going to be really useful to, and I think probably corresponds with our sort of initial thinking in some areas, but where there's some outliers, it'd be really useful to understand those and get to the bottom of that. So yeah, no, that's brilliant. Thank you very much indeed. Yeah, and hopefully if people are browsing around that, people on the call, as we look at it and interpreting it in, sort of in your own context, then that hopefully is useful, and we'll maybe bring some of the points that come out of that into the discussion when we get to the end of the presentation. So great, thank you very much. Yeah, okay. So that then takes us on to the final set of questions in the Exelite, which if you can bring those up, Mark, that would be great, please. Thank you. Yeah.
So these are the questions on opportunities and barriers.
Yes, please. Yeah. So I think there's three areas where we have the opportunity to again enter into sort of a free text comments and discussion around the key issues. So we've got most significant opportunities or drivers it might be for your business or sector, and the most significant barriers. And we've also got a third sort of general commentary, other observations, other points that you may wish to make as an option in there as well. If you scroll down on the screen, that's it. Yeah, any sort of just general notes or observations. So welcome everybody going into those boxes and so that they entering into some further sort of discussion and observations, particularly specifically the opportunities and barriers that are relevant to your sector, or that you see are particularly relevant to your deployment of carbon capture. That would be very helpful. Thank you very much. As I said before, we'd ask that your responses here are based on the assumption that there will be a transmission storage infrastructure in place, sort of in a cluster model, as currently being supported by BEIS, and that there is a clear, and also assume that there'll be a clear business model support for deployment of carbon capture in the UK and your industry in answering this. So that we don't want to consider those as sort of they're kind of universal barriers at the moment, but we're looking at 2030, 2035 when the first clusters hopefully will be deployed and available. Access to those clusters may be an industry-specific barrier, but in general terms, the fact that at the moment there's not an operational UK sequestration site shouldn't be an industry-specific barrier. Okay, so see, we've already got some useful contributions been made, so thank you very much. That will give maybe 5 or 10 minutes here just to allow that discussion to develop and get those comments down. Thank you very much, and then we'll move back into the last bit of the presentation before we then get into the direct discussion. Okay, it seems there's some very good discussion and some really useful points coming up in there. Thank you very much. We'll perhaps give it another couple of minutes and then move back to the last part of the presentation, and maybe actually again, say I'll have to give it another 2 or 3 minutes and then leave that on in the background while we hand over to the next bit of the presentation. Okay, so I think the rate that comments are being made is probably slowing down a little bit now. So as I say, I think Mark, if we can leave that in the background, and people please feel free to continue adding comments and thoughts as they come to you and as the dialogue develops. But in the meantime, we'll return to the presentation and hand over next to John Gordon at BEIS, who, if you can return to the screen share through Zoom. John's going to talk you through how this study fits into some of the specific next steps in the NZIP program, and what the sort of the main deadlines and sort of milestone dates are in that program. Before I hand over, I'll just mention that we are intending to hold a second industry workshop as part of this study, which will be held in January 2022. And the intention there is to give everybody a progress update, and also provide an opportunity for some of the technology developers to present their technologies and demonstrate how they apply maybe in the different sectors that we're considering in the study. And so that the purpose of that workshop really is to help disseminate sort of some of the initial findings and some of the opportunities there are for site operators and to adopt carbon capture as part of the route to decarbonisation. So that's my plug for that next meeting, and a date will be fixed for that fairly soon and circulated to everybody that's been on the call and more widely. But then now I'll hand over to you, John, if you're there, and let you talk through some of the other key dates in the NZIP program.
Oh, give me just a moment. Hopefully you can all hear me.
Loud and clear.
Hi, my name is John Gordon. I'm one of the program managers on the CCUS innovation program with Nick, and I'm just going to talk a little bit about some of the programs that we've got within BEIS that are looking at net zero, and specifically the net zero innovation portfolio, where we've got up to £1 billion in grant funding available for several different themes. I'm just going to talk about 4 of them just now. So today you've been involved in part of the CCUS Innovation 2 grant funded competition. As part of that, we've got Call 1, where we've just closed the competition there, where we've had £13 million funding available. Announcement of successful applications will be made over the next few months. We've also got the research study, which is ongoing at the moment, which AECOM are facilitating today with the workshop. So that study is due to finish at the end of April, and that should coincide with the launch of Call 2 for CCUS Innovation 2. We're due to launch that in May next year. More information will become available probably around January, February time for that. And there'll be up to £6.5 million of grant funding available. The projects will last up to 30 months, taking us to the end of March in 2025. And the funding will be split into 2 categories. So we'll have Lot 1, which is looking at mid-stage CCUS innovation projects, and that's up to £1 million of project funding available in that pool there. And then in Lot 2, we've got up to £5 million available, and that is within the late stage CCUS innovations. That's TRL 6 to 8. We'll also include feasibility studies, which we're looking to fund as well. So we will provide more information of Call 2, so both lots and the feasibility studies, as we approach May next year. And move on to the next slide, please. So one other competition that we've got, and I'm going to just name off 3 in the next 3 slides. So we've got industrial fuel switching 2, which is part of the net zero innovation portfolio, which I mentioned. So applications for that open on the 11th of October. In this competition, we've got £55 million available, and we're looking primarily at fuel switching. So it's split into 3 lots. Where we have Lot 1 of hydrogen, Lot 2 electrification, and Lot 3 is looking at biomass and waste and other options there for fuel switching as well. So more information of that can be found on the gov.uk webpage along with the CCS Innovation. We're also holding a launch event on the 12th of October, so that's in the next couple of weeks. The link is there. If you're interested in attending that event, it will be on Microsoft Teams, similar to the event today, and you have an opportunity to put some questions to the team which are running that competition. So that's another one that we've got, and just that's £55 million worth of funding, if you're interested in planning for that for your industry. And on to the next slide, please. The second competition I'll talk about is red diesel. So red diesel tax changes are coming in, coming into force quite soon. So in preparation for that, we've got the red diesel replacement programme, but we're looking to swap out red diesel as a fuel. So it's in construction, mining and quarrying sectors. I think it's non-mobile road machinery, which is the classification for that. And we're looking at alternatives for that. So just read this off. So it's developed in response to the partial removal of the entitlement to use red diesel and rebated biofuel, so from April 2022, so that's yet in a few months. And there's £40 million of grant funding available to develop low carbon alternatives to red diesel in those sectors. And below is just a timeline of that as well. So we launched it just a few days ago, phase 1. You can submit questions up to the 15th of October. To the team. Again, more information of that can be found in gov.uk. And the 22nd of November is when applications close, and we'll begin to inform applicants in the beginning of next year when they've been successful, and then we'll look to start kicking off the projects on about there. So if you'd like to find out more information about that from red diesel replacement competition, then head to gov.uk net zero innovation portfolio, where you'll find information on that. Next slide, please, Caris. So the third area that we're looking at is Industry of the Future programme, scope and study phase. Industrial sites competition aims to increase the range of options available to industry to enable them to decarbonise at a faster rate. So yeah, this is just some more information on that scope and study phase. So you have a look at gov.uk. The registration forms are open to the 14th of October. To have a look at gov.uk on that one. Next slide, please. And that's it from me. I'll pass it back to Andy and Clem at AECOM.
Right. Thanks, John. Yeah, very useful. Lots of money on offer. Okay, so I think at this point, this is the stage at which the recording will stop when we've been through this slide, and then we'll use the remaining time to open up the meeting to an open discussion to allow an exchange of views on all of the issues covered, or new ones if you have them. And John Gibbons is going to chair that, and I think probably slightly change the sort of the format of the dialogue and the comment formats. But John will talk a bit more about that when I hand over to him. But in the meantime, I just say that if you don't want to present your views in this forum or sort of break your confidentiality or need to leave now, we have set up a project email address, which is the address is on the screen there, and you can submit your comments and views or any other observations through that, and we'll be pleased to receive your thoughts. I think we've had one other question on the chat about whether we're able to share the results of the XLEAP sessions and the results of those and the numbers that came through from that. That wasn't the intention at the moment. We'll certainly use those results to inform the review and possibly include, a sort of summary of the results as part of the reporting from the study. But we'll perhaps look into whether a full sort of dissemination of the results is possible in the meantime. So yeah, thanks for that question. We'll take that away and see how we can present that. Okay, so before I hand over to John, I just wanted to say thank you very much indeed to everybody on behalf of AECOM for joining the call today. Thanks for all your engagement and very useful contributions and points in discussion. We'll be looking forward to spending some time in the next week or two picking through those and trying to take account of all the useful comments and look at the trends that are coming out of that.